Well, hello Internet, and welcome to my Pandas video tutorial. In this one tutorial, you're going to learn pretty much everything you could ever want to know about pandas, all in one video. And this is part 4 of my data science and machine learning course. And basically, Pandas is going to provide numerous tools to work with tabular data like you'd find in spreadsheets or databases, and we'll be working with spreadsheets and databases. And it is widely used for data preparation, cleaning, as well as analysis, and it can work with a wide variety of different types of data and provides many visualization options. And I'll be using Anaconda in this tutorial just because it's easy, and you can see all of the different topics that we are going to cover in this course, so a whole bunch of different things. And underneath the video, you'll find a table of contents to jump to whatever you're interested in. And at the very end of the video, I show you how to install everything if you need to do that, as well as install all the libraries you're going to need. And now let's get into talking about series. Now, series are going to be built on top of NumPy arrays. And to create a series, I'm just going to say list1 is equal to, and let's just throw some letters inside of here. And the other data structure you're going to be working with, which I'll talk about next, is DataFrames. And they are two-dimensional data structures, while series are one. And each are going to be able to hold multiple different data types. So we got our list. And now what I can do is define that I want the series indexes to be provided different labels, and let's just keep it simple and just say the labels are going to be 1, 2, 3, and 4. And then to create our series, I'm going to say PD series and pass in as data list1, and for the indexes, I'll have that be the labels. But however, before I create the series, I need to import some libraries. So I'm going to need to get NumPy, and I'm going to need to get Pandas. And like I said, at the end of the tutorial, you can jump there in the table of contents. You'll find out how to load all of these different libraries inside of here. Now to go and actually create this series, I go PD, series, pass in the data, which is going to be list1, and then the labels are the indexes. And I can create or see the series that I have, and you can see there it is. You can also add a NumPy array. So let's go and create one. And I have a NumPy tutorial if you want to learn more about it. So we can go NumPy array, and 1, 2, 3, and 4. And let's create another series here. And you can just click on tab whenever you're doing this if you want to save yourself some time. And I'll put in array 1. You can also set it up by using a dictionary where you can quickly add labels as well as values at the same time. So let's say I have first name and Derek, last name and my last name, as well as age. And then you can take this dictionary and create a series just by passing the dictionary inside of there. And there you can see that. Now you're going to be able to get data just by using the label. So if I want to go and get the first name, I can do that easily. You can also come in and get the data type. So let's say dtype, and you can see that is a 64-bit integer. You're going to be able to also be able to perform different math operations on series. So let's say we want to add them together. You can see that worked. You're also going to be able to subtract. There's that. You're going to be able to multiply them and divide them. And I'll show you a whole host of other different ways we can interact with them mathematically. You're also going to be able to pass them into NumPy methods. So NumPy and series 2. You can see how that works out. And the main difference between series and NumPy arrays is that operations align by labels. So let's create another series here using a dictionary. So I'll say PD and series, and then inside of here, 4 and 5, 5 and 6, and 6 and 7, 7 and 8. I can now come in here and go series 2, plus series 4. And whenever I do, they do not line up based off their labels. And that's the reason why you're not able to add them together. Series 2 in this situation, if we go and print it out, so series 2 has the labels 0, 1, 2, and 3. Well, these labels are 4, 5, 6, and 7. And since they don't line up, that is the reason why you can't add those together. All right? And if this isn't all confusing, numerous examples are going to make it easier to understand. And you're also going to be able to assign names to series. So we'll say name, and let's just call this random nums, like that. And then you can go and get the name assigned to it. All right, so there's a brief introductory to all the different things you can do with series. And now I want to talk about data frames. Now, data frames are going to be the most commonly used data structure with Pandas, and they are also made up from multiple different series that are going to share the same index or label, and they can contain multiple different data types, as I said before. And once again, they can be created with dictionaries, series, lists, and other different data frames. So let's show you how to create some data frames. I'm going to say array2 is equal to np and random int. And what I want to do here is I want to create a 2x3 matrix with values between 10 and 50. And then you can define your size using a tuple. So 2x3. And there you can see that random values are generated. You're also going to be able to create data frames by passing in our array here, along with your row columns, which is going to be A and B, as well as your column labels, which is going to be C, D, and E. And there you went and created one. Okay. And you're also going to be able to create a data frame with multiple series. So let's create a dictionary here. And we'll say 1 and use the series to generate this. And go and define some values. I can go 1, and I'll make this a float, and 3. And then come in and assign our indexes with B and C. And then do basically the same thing. So let's just copy this out of here, paste that inside of there, and let's change this to 2. And let's make this slightly different. Let's go and throw 4 in there. And then let's go and throw in another index here. And let's create our data frame. PD and data frame, and throw our dictionary inside of it. And you can see there is our data frame. And you can also see it has nan inside of there because there was no value assigned right here, but there was a value assigned right there. And I'll get more into cleaning data later on. I'm also going to show you a function called fromDictionary, which is going to accept column labels and lists. So let's go PD and data frame and fromDictionary, and go dictionary. You have to pay particular attention to whether you're using parentheses or brackets. So let's label this as A, and then we'll throw in some values, 1, 2, 3, and then throw in another one. Let's label this B, and 4, 5, and 6. You can see what that looks like. And let's create another one. Let's say data frame from dictionary and dictionary A, and 1, 2, and 3. Might as well just copy this and paste that inside of there. And now what we'll do, and I'm going to show you how to assign the keys as row labels and column labels separate. And you're going to do this with orient to the index. So you say orient is equal to index, and then columns is equal to, and let's have these be 1 and 2 and 3. And I had one too many brackets in there and parentheses. And there you can see is our answer. All right, so good stuff. And finally, before we start doing some more interesting things, if you'd like to go and find out the number of rows and columns inside of a data frame, you can go df1, and you're going to get a tuple that's going to provide that information. All right, so some good stuff there. And now we're going to get into more advanced things where I'm going to show you how to edit as well as retrieve data from a data frame. Okay, so now I'm going to show you a whole bunch of different ways to edit and retrieve data. And I'm going to show you some common ways to receive data. So let's say we have df1, our data frame, and we want to receive that. Let's go and show you what that actually looks like as well. Okay, so you can see that we were able to go in and retrieve that whole entire column. You're also going to be able to come in and get multiple different columns. So let's say you want to get C and E. You're going to be able to get both. Just pay particular attention that there are 2 brackets on the front and 2 at the end. You're also going to be able to grab a row as a series. So we'll say location and A, and there that is. What else can we do? We can also grab a row by index position, and you do that with I, location. I'll say 1, and there's that. You can see it's updating right here where it says out. We're also going to be able to grab a cell with a row and a column. So we're going to use location again for this. And then you just list your row and the specific column you're looking for. We're also going to be able to come in and get multiple cells by defining the rows wanted as well as the columns for each of those. And again, we're going to use location. Just make sure you use double brackets here. And then separated with a comma, your columns, which will have be D and E. And there you go. You're also going to be able to come in and make new columns. So let's say that I wanted to come in to our data frame, create a new column. It was going to be called total. And what I want to do is I want to add up the sum of all of the other different columns. Well, I just list those individually and then add them together. So do the same for D and do the same for E. And output that. You can see it shows up. You're going to be able to perform multiple different calculations. As you can see, I printed out our df2 data frame. And let's go and create another one here, df2, and let's call this multiplication, which is going to be equal to df2. And then I can go and grab the individual columns for that, which are labeled as 1, and then multiply those times each other. And you can see how that changed. Let's come in here and let's also make a new row. So I'm going to create a dictionary, and it is going to have the column of C, and I'm going to give it a value of 44. I'm going to create another column D, give it 45, and E, and give it a value of 46, and then go new row is equal to, create a series from this, throw our dictionary inside of there. I can go and give it a name of F, and then go df1 is equal to df1, and what we'll do is append our new row. And you can see it through those values inside of there, but total did not work with it because total's not set up to work with it. Now we're also going to be able to come in here and delete columns. So let's say I want to go df1, and what you're going to do is use drop with this, and I'm going to say that I want to delete total, and I'm going to say axis is equal to 1. That's a way to reference the column named total. However, if you want it to actually delete the data, you have to understand that Pandas tries to protect your data, and even though you issue this command, if you do not list in place true like that, it will not delete that column for you. But if we go like this, and then we go and show it, you can now see that it is indeed gone. All right, do a couple more here. Let's say that I want to delete a row. Again, we're going to use drop for this. So we can say drop, and I can say I want B, and you're going to use axis equal to 0 for rows. And again, I'm going to say in place is equal to true. And you can see that it has been replaced as well. See, B is no longer here. Another thing we're going to be able to do is create a new column and make it the index. So what I want to do is I'll say df1 and sex, for example, is equal to men and women, and I can set it as the index by using setIndex and list sex and in place. Again, you have to put in place in there if you actually want it to go through. And I have a little bit of an error because I went and dropped these different rows and then I tried to drop them again. If that ever happens to you in Anaconda, you can just go control and run this up here. Because I have my data frame created up here, then I drop the tables down here. So that's sort of caused some problems. So I'm going to get rid of these drops. So if you have that issue, that's what's causing it. And if I reload that, you can see that they show up. Another thing you can do is you can just go and click on Cell and Run All, and that will allow you to keep running those. But either way, you normally will not use Anaconda the way that I'm using it, where I'm just jumping and doing all these different things and causing such massive changes. All right, another thing, and this is going to mess it up as well. What I'm going to do is show you how to reset the index values back to numbers. And you would do df1.reset index. And again, you have to do in place equal to true for this to work. And whenever you do, it'll switch back. I'm not going to do that because it's going to mess this up even further. You're also going to be able to use assign. And it's going to be used to create a column while leaving the original data frame completely untouched. So we can say df2.assign, and I'm going to have a division done here on different cells in our data frame. So we can go 1 divided by data frame and 2. And you can see that division shows up there in the final results. Another thing you can do is with assign, you're actually going to be able to pass in a function. So let's go get division here. Actually, let's just change this whole entire thing. And we can put a lambda inside of here, x. And what it'll do is it'll go through and divide all those different terms, right, like this, and x and 2. And you can see it did the division as well. Another thing we're going to be able to do is combine data frames. So I'm going to create a data frame 3. So data frame. And if anytime I'm going too fast for you, just hit the pause button. That's what it's there for. What I'm going to do here is I'm going to create a null or nan value inside of here. So it'll be like a lack of a value. You're going to come across this a lot, and I'm going to show you how to clean this up later on. So we have our first new data frame here. And I'm going to create data frame 4. And it is not going to have any null values. So I'm going to go inside of here like this and go 8, 9, 10, 2, and 4. And what we can do is combine these with combine. And I'm going to use combine first specifically. And what it will do is take the first data frame passed inside here and this guy and combine it with the data that is inside of here. And it's going to keep the data here unless there are nan values. And in those situations, they will be replaced with the second data frame, which is df4 in this situation. And if we output that, you can see we get the results that we would be expecting. All right, so there is a whole bunch of ways to both edit as well as retrieve data using pandas. And up next, I'm going to show you conditional selection of data. All right, so let's create a random numpy array and random int 10 to 50 and size. I want this to be a 2 by 3 array. And there you can see it is. Now I'm going to create df1, and this is going to be a data frame. Just want to reiterate, if you're ever having any trouble, try doing cell run all, and that will probably make your problems go away. Okay, especially if you're doing this in this tutorial. Like I said, you normally won't be doing things like this though. All right, so what we're going to do is set up our data frame just like we did previously. And this is going to be our columns. The A and B are our rows. And I'm going to print out this data frame because we're going to be referencing it a lot, even though it's going to be random and changing a lot. Okay, so you're going to be able to use conditional operators to retrieve a table based off of multiple different conditions. So let's come in here, and I'm going to say that I want values that are greater than 40. And I'm going to throw a new line in there. And then I'm going to use our data frame and just say greater than 40. And you can see that it comes back true in situations which the value is indeed greater than 40. Now you're also going to be able to use other different comparison operators. So for example, I would be able to say df1 and get rid of this part and change it to gt and 40 like this. And all of them were false in that situation. There you go. Now you see 49 comes in there. And there are a whole bunch of them. If you don't want to use the regular old comparison operators, you can use gt, lt for less than, greater than or equal to, less than or equal to, and not equal to. Okay, so all those are available to you. You're also going to be able to place conditions in brackets as well. So let's go and create bool1 here, and this is going to be a condition. So we'll say 45, and then I can say df1 and bool1, and you can see that that also is going to work for you. So you might want to put those in an array and run all these different conditions based off of the different conditions inside of the array. You can also get booleans for a column. So let's say we want column E greater than 40, and just keep on stacking these. Let's say we wanted to return a row if the cell value in the column matches a condition. How we do that is we stack up these data frames. So we say data frame, and then we specifically ask for column E, and we say we're looking for values that are greater than 30, and nothing came back, so that means nothing was great. And there we go. Now we got some stuff. You're also going to be able to focus on a column based on a resulting data frame. So let's go and create data frame 2, data frame, and data frame 1 anyway. And again, we're going to be working with column E greater than 30. Then you're going to be able to say data frame 2, C. All right, what else can we do here? You're also going to be able to stack these commands. I'm going to do a print on this. I'm going to say data frame 1, and again, I'm going to be focusing in on data frame column E greater than 20, and you're going to see more of this technique later on, and you can see the result of doing that as well. Again, your answers are going to be different than mine because everything is random here. You're also going to be able to grab multiple different columns, so you could have C and D inside of here. Just make sure, and you can see the answers right there. Just make sure you put extra brackets around the two different columns that you're working with. And you're also going to be able to use multiple different conditions. Let's go create another NumPy array. And let's make this be 1, 2, and 3, 4, 5, and 6, and 7, 8, and 9. Go and create a data frame and pass in our new array inside of there, as well as our rows and our columns. So just keeping this fairly simple. And our columns, let's make those X, Y, and Z. All right, so we got that generated. And let's go and print that just so you can see it as we perform these multiple different conditions inside of here. Okay, so then what I'm going to do is I'm going to say that I want data frame 2. And then I'm going to put our multiple conditions inside of here. That I'm using parentheses here once again. So here I'm going to say df2 and x greater than 3 and df2 x less than 7. And if I run that, you can see that 4, 5, and 6 come back on top of that. So that's how we can do multiple conditions. And if you want to use or instead, there you go, just use the pipe symbol. So that is how we can perform different conditional operations on our data frames and our series and so forth and so on. And now what I want to do is show you how we can use file IO to import and work with numerous different types of data. Okay, so as you can see, Panda is going to be able to work with a lot of different types of data, a ton of it. Actually, I don't even have it all there. And if you didn't import all the libraries required, and you're going to have some issues here. So again, you can refer to the end of the tutorial. I'm going to be working with MySQL, so I'm going to use PyMySQL. You can use any database you can imagine, and you can go and search in the environment for your specific database you want to do that. And also there's a link to GitHub account that has all of these files, except I don't have my database. You're going to have to create your own database if you want to work with databases. But I'm going to show you how they work. Okay, so let's say you wanted to read in a comma-separated value file. What you're going to be able to do is actually, if you want to see all of the different types, I didn't list every single thing. You can just go like this, read, and then tab, and you're going to see all of these different file formats we're going to be able to work with. So there's a whole bunch of different things inside of here. I'm going to show you a bunch of them though. Go, comma-separated values, and this one is called computer sales, CSV, and I can say computer sales, DF, and run that, and it's going to show me all of that information that it pulled from that file. So pretty cool stuff. Let's say that I would want to, I go and make changes to a data frame, and I want to go and save it as a CSV file. I can say CS DF to, and you can once again tab and CSV. And let's say that I would like to make a backup of my computer sales CSV file. I can do that. So that's how you copy a data frame to a CSV file. We're also going to be able to read data from an Excel file. So to do that, go PD and read Excel. And I have one inside here. Just make sure that they are in the same directory as wherever you are running this. Otherwise you will have trouble. So sample and XL SX. This is just something I randomly pulled off of Microsoft's website. And you can see all that information. You're also going to be able to write to an Excel file. So let's go and get my computer sales thing here and say that I want it converted into Excel. And we can save it as computer sales. Let's say backup XLSX. And that's going to take that data frame and save it as an Excel file. We could also come in here and check if it was written or not. So I'll say pd.read Excel and then go and get this whole entire thing right here, paste it in there, and you can see that it was indeed read into that Excel file. We're also going to be able to read from databases, any type of database. I'm going to use MySQL here because it's most common. So what we need to do is create a connection to our database. Well, first off, we need to say try. Then we need to create a database connection. So database connection is equal to, and I'm going to use PyMySQL and connect. And then I need to say the database that I want to work with. It is called students. And then I have to list a user that's going to be able to access it. So that's going to be student admin. And I have MySQL tutorials if you don't know how to use MySQL. I need to provide a password. Please, whatever you do, never use this password because this is always the password that I use in tutorials. So turtle dove. And host is going to be, more than likely, this will be your host as well as your port. So port is going to be equal to 3306. Otherwise, you need to look up whatever your port is for your specific database. All right, so then I'm going to go get my student data frame, and I'm going to read the data from it. So I'm going to say read SQL, and then I put a query inside of here, which is just going to be select everything from the table called students, and then our connection is going to be DB connection. All right. And then if I want to, well, then I'm going to say if there is some type of exception, I can say exception as E, and then I can print out that there was an exception, an error when trying to access the database, whatever that might be. And I'm going to say format and E. And before I get to that, if I would like to print out my student information, I can say print student df, and down inside of here, that's going to be a catch-all for all the exceptions. And what I always want to do is I want to come in here and close the connection after I'm done with it. And if I run it, you can see I was able to go in and access and pull all the information out of my database. And it's in a data frame that's totally usable. Okay, so cool stuff. Let's come in, get rid of that where I print this out. And now what I want to do is show you how to convert a data frame, or actually I'm going to show you how to insert one value. put this on a loop if you would like, as you can loop through a data frame and put that in as well. So either one's going to work for you. So again, we're going to have exactly the same thing where we're going to connect. So I'm just going to copy this right here. DB connection. There we are, all the same information. And then I'm going to create what is called a cursor. And it is going to be used to make queries for your database. So DB connect and then cursor. I'm then going to create a query. I'm going to call this insert statement. And I'm going to insert myself into this statement. This is just a MySQL query that inserts first name, last name, email address, street, city, state, all of that stuff. So that's what you're going to put inside of there for that. But your database will be completely different. But that's the way it works for what I got done here. And everything's going to be the same. You're just going to use different insert statements, that's all. And then if you want to execute the query, you say cursor, execute, and insert statement. And then you have to commit the changes to the database. And how you do that is you go DB connection and commit. Otherwise it won't update. And then what I can do is I can go create student data frame and PD read SQL. And again, I can select all of the students inside of there. So let's just go and copy this again, just to see if it updated the database or not. So there's this, paste that inside of there, and then close that off. Whoops, don't put it there though. No, that's not right. Okay, good. And then I can print this out to see if it went and updated my database. And again, you're going to do exactly the same things for your exception and then finally closing your connection like that. And if I run it, you can see that I am now inside of the database. All right, so cool stuff. And one other thing I want to do before I leave, let's say inside of your CSV file, if you just wanted to get one column's worth of data, I'm going to call this CSDF, and this is going to be state equal to, and I'm going to say PD and read CSV, and I'm going to list computer sales. This is something that you do a lot. That's the only reason why I'm doing it. So if you just want to grab one column outside of the CSV file, then you're going to say use columns equal to, and I'm going to say that I want just the states, and you're going to say squeeze true, and then I can say CSDF state, and it's going to output all of the state information. All right, so good stuff. Whole bunch of different ways to work with files, and I think you'll be able to work with even more files if you go and play around. Like, for example, you can work with doc files and things like that. But what I want to do is jump over and show you some basic things. You're going to use a whole bunch, and then a whole bunch of different math functions that are available. All right, so now I'm going to show you a whole bunch of commands you're going to use a lot. So let's say that I take my computer sales data frame, and I just want the first 5 results. That's how you do that. And if I would like to get use head. And if you want to use the last 5 results, you use tails or tail. If you want to come in here, and let's just do this again. And let's say you wanted to get the first 2, you can do a slice like that. Another thing you can do is, let's say you would like to get the first, that's actually what this does. This part being empty means you want to start from the beginning and you want to get the first 2. That's what that means. Let's say you would like to get the first 5 and you would like to step through 2 at a time. Do that, and then you can get those results. All right, another thing you'll be able to do is you're going to be able to get indexes. So let's go and get this guy, and index and array, and there's all my indexes that I have, and I can go and get a NumPy array from this just by going like this and saying that I want to convert it to NumPy. If you saw my NumPy tutorial, you saw me do this, and there is all that information as a NumPy array. You're also going to be able to get an array from a series. So let's go and use our series 1 array, and there that is. And let's go and create another data frame to work with. I'm going to create this using a dictionary. I'm going to call this dictionary 3 and 1 and I'm going to create a series here. So it's going to go 1 through 3, and then I'm going to label the indexes as A, B, and C. And then we'll also have another one, and this is a series as well. Label this as 1, 2, 3, and 4 with our indexes equal to A, B, C, and D. Okay, so we got our dictionary created. Create our data frame and data frame and use our dictionary to do so. All right, so now that we have that, another thing to know, I'm going to cover this in more detail later, but you're also going to be able to replace any NaN values you have inside of your data frame with fill NA, and I'll replace them with zeros. And you can see there that I don't have any. But if I insert one inside of here, np.nan, like that, whoops, nan. Now you can see it was indeed replaced right there. Okay, so just something to know. But I'm going to turn that back into a 2. And there's a whole bunch of other different ways of replacing, like I said, that I'll cover later. Okay, so now let's say I want to get the values in row 2. Say df2, index, location, 1. And what I can do here is actually add items in row 2 to all the other rows, including row 2. So I'll say df2 add row and axis, and you're also going to be able to use axis column as well. And you can see that I was able to take what was in row, well, let's go and actually print that out. So print df2, okay, so there they are. So what I did was I took all these values 1, 2, 3, and 4. I added them both to themselves as well as to row 1. And you may not have noticed I put in place here. That allows the change to take place in our data frame 2. Without that, it wouldn't take place. Now let's say that I want to get column 2, df2, and with the name of 2. And I'd like to subtract that from all of my other columns. I can do so. df2. Subtract column and axis is equal to 0. And now you can see the changes I made there. Another thing we can do here is we can check if our data frame is empty. Obviously, ours is not, just by following it with empty. And you can see it comes back as false. And now I'm going to show you how to do a whole bunch of different things with transform. What transform is going to do is it is going to execute a function on a data frame. So let's go create another data frame. I'm going to call this df5 and data frame. And I'm going to do everything right here inside of here. So let's say I want a range, 3 values, and B, and range 1, 4, df5. You can see exactly what that outputs. Okay, so now we got that. And what I want to do is, let's say I wanted to add 1 to every single value inside of there. I could just say transform lambda. And I could do this with built-in functions as well, of course. X plus 1. There we are, added 1 to all those values. Let's say I wanted to take them all to the power of 2. Did that. Let's say that I would like to get the square root of those values. Just get rid of this part. NumPy square root of x. And there we are. And you're actually going to be able to transform using multiple different functions. So let's say I wanted lambda and I wanted to get to the power of 2, but I also wanted to get to the power of 3. And you can see that it performed those actions as well. Just make sure you put the brackets around both of these 2 functions that you have inside of here. Now, something else that's interesting is passing a dictionary is going to allow you to perform different calculations on different columns. So let's go get our data frame here, and we'll say transform A, and our function, I'm going to say lambda x, and take that to the power of 2, and then do basically the same thing again. But let's go and take this to the power of 3. And you can see it labeled those 2 different function results with A and B because that's what I labeled them as. Map is going to perform similar functions. What it's going to allow you to do is perform a function on a series. So I'm going to say df5 A dot map, and I'm going to say lambda. Again, just to keep this simple, I'll just take it to the power of 2, and there's the results. Apply map is going to do the same for a data frame, so we can say df5 and apply map, and let's just let that be the same, and there's your results. Another thing we can do is we can get unique values. So let's say we wanted to get unique values in column 2. How would we do that? Well, we'd say df and 2 and follow that up with unique. And you're going to see it gives you all of them because they're all unique. But if you go and have duplicates in there, it's only going to give you the unique values. You're also going to be able to get the total number of uniques just by putting an n in front of that. See, that comes back as 4. You can also find out the number of times a value showed up in a column. So again, we'll use 2, and you use value counts for that. Whenever we start doing real-world examples later on in the tutorial, you're going to see how you can do some cool things with value counts. You can also get column names just by asking for columns, with a period here. And we'll also show you how that's useful. You can get index information as well, just by typing in index. And then we can also return a data frame that lists any null values as true by calling isNull. And they'll come back as false. All right, so there are some basic little commands that you're going to be using a lot, along with a ton of things you can do with math functions. And up next, I want to talk about grouping data. All right, so I went and created a dictionary with some different data on 2 ice cream stores. I have ice cream store 1 and 2, and then we're going to have different flavors of ice cream that are going to be matched up with sales data. And then, of course, I created a data frame from that. So I'm going to talk about a function called group by, and what it's going to allow you to do is group rows based off of columns and perform a function that is going to combine those values. And when a function that combines values is called an aggregate function. So what I want to do here is I want to group data by the store number. So I'm going to call this by store equal to df11, and I'm going to say group by store. Okay, now what I can do is I can come in here and go by store. And let's say, we're going to get into statistics functions later, but let's say I wanted to get the mean. Oh, I typed in by score. This is supposed to be store. There you go. So I was able to get the mean value in sales for both of the stores using that. Let's say I would want to get the sales total just for store 1. Again, by store and sum dot, and I'm going to say location 1. Is what I was looking for. And you can see I got a total of 44. And you're also going to be able to use a function called describe to get a whole bunch of data. So you're going to be able to perform these functions on all this stuff. So there's describe, and you can see all the information you get all at one time, and you can go and get the standard deviation and count and all these other different things by calling those individual functions on those groupings. All right, so real quick overview of grouping data and performing different functions on said data. And now I want to talk about how we can concatenate, merge, and join data. Okay, so again, created 2 different data frames here. And if you would like to concatenate these together, you could just say concat. Pretty simple. And then inside of brackets, you are going to list them in order that you want them to be concatenated. And you can see how easy that is to pull off. And I went and created a couple more data frames. You're going to notice here that instead of index that we're now working with key. And let's say that you would like to merge 2 data frames using their shared key column. All right, you can see that the key columns are the same. You're going to be able to say PD and merge. And there's a whole bunch of different ways we can merge data. So we'll say df12 and df13, and you have to define how you want it to be merged. I'm going to merge this using an inner join, and what it does is it merges at the intersection of our keys, and I have to say what the name of the column is, which is keys, or key to be specific. And you can see that we were able to merge that data together. Now, if you would use how and left, or you used how and right, you're going to define if you want to use the keys from the left or the right frame. And then you also have outer. And if you use that, that is going to be the union of the keys. Okay? So different ways of working with that data. And I created 2 new data frames here. And now what I want to do is show you how to join those data, or those 2 data frames. And what's interesting here is you're going to be able to join data frames with different indexes, and instead of using keys, instead you're going to use columns. So we can say df12 and join df13, and you're going to define how is going to be equal to outer. And like I said, this is going to be the union of the keys. And if I run that, you can see exactly how that loads. And you're also going to see you're going to have NaN values anywhere in which they do not line up. Okay, so that is basically how you concatenate, merge, and join data. And up next, I'm going to show you a whole ton of statistics functions. Okay, so this is some data in regards to ice cream sales. You can see here temperature and sales, and the whole point of this is to discover as the temperature rises every single month if ice cream sales also rise. All right? Okay, so what I want to do here first is I loaded that data and I displayed it. Let's say I'd like to get the total count of both of the columns. I can say ICS and DF and count, and that's going to give me that they are both 12. Well, there's 12 months in a year, so that makes a lot of sense. Let's get into deeper stuff here. Let's say, well, let's go, instead of that, let's go ICSDF, and let's say that I would like to sum these values. I can say sum, like that. And if in situations, and this is going to be true a lot, in situations in which you want to skip any NaN values, just say skip NA is equal to true. And I don't have any NaN values, so that doesn't matter. And another thing to know is if you have sum inside of here and you hit question, like let's say you don't know what the attributes or parameters are for this function, after you type in the function, you can actually go shift and tab, and it's going to show you all the different parameters and attributes you're going to be able to use with that function. So very, very useful, shift tab after any function name. All right, so that is how we sum those values. Now let's say that I'd like to come in here and get the mean for our sales column. I can come in and just type mean afterwards, and it will give me the mean. I'm also going to be able to get the median just by typing in median. I'm going to be able to get the mode like that, and there is our mode. I'm guessing there's 2 of these sales that come up with the same value, so there's mode. We're going to be able to get our minimums and our maximums. So min and max, they're the total sales, min and max. We'd be able to come in here and get the product of the multiplication of all those sales data, and you can see that is a huge number. We'd be able to get our standard deviation just by typing in standard deviation. Be able to get our variance like that. And if you don't know what any of these mean, watch my statistics tutorial. I cover them in massive amounts of detail. You also will be able to get your standard error by typing in SEM, and it just keeps on going and going and going. Let's say that you want to find out how the results would skew on a graph. You just type in skew. And in a situation in which this value comes back as negative, that means it has a long tail towards the left. If it's a positive, that means it has a long tail towards the right. And if 0, that means it's pretty well spread out. Another one is kurtosis, which is just short right here for Kurt. This is very useful because it's going to tell you very quickly how many outliers you have in your data. So if it's less than 3, that means you have few outliers. If it is at 3, that means you have a normal distribution. And if it's greater than 3, that means you have a lot of outliers. You can also get different quintiles of your data just by typing in quintile and whichever one you would like. So let's say 50% quintile. Oop, I have to spell it right though. And there you are, and there's your data. You can also get a cumulative sum of your data as well, which is going to be useful in certain situations and other situations not so much. You can also get a cumulative product, which again is a gigantic number. You can see we overrode here, so that's a bad thing. You're also going to be able to get your cumulative max, and you're going to be able to get your cumulative minimum, right like that. You're also going to be able to come in and let's say that you would like to get a whole bunch of these things all at once. You can just call describe on all of them and get all that data from both parts or both columns. And let's say I want to do some work here with dice now. So here's a series with a whole bunch of different dice results. What I can do with this guy is I can say that I want to get the value counts for all of these different dice rolls. And you can see the odds of getting all of those, 7 being the greatest, of course. And then you're going to be able to perform different calculations on multiple different columns. So we have, let's say we wanted to do DF2 with this. I'm going to print out DF2. So there is DF2. And let's go and get the mean. So I'm going to say DF2 and aggregate and use the NumPy mean. And you can see I got the mean values for both of those columns. And you're going to be able to do this also with multiple different functions. You just have to put them inside of brackets. So let's go get rid of this part right here. And then inside of brackets, we're going to type in mean as well as standard deviation. And you can get both of those at the same time. And I think that's a good rundown. Okay, so there's a whole bunch of statistical things you can do and mathematical things you can do with pandas. And now I want to talk about iteration. Okay, so I went and created a couple different types of series as well as a data frame. So a series and a data frame. And I'm going to show you how to iterate over this information. So we can just say for, and this is for our series, column in series 7. And then I could just come in here and I can do anything I want with this, but I'm just going to print them out. And you can see how easy it is to cycle through those. You're also going to be able to iterate over your data frames. So to do that, you're going to be able to say for label series in df8 items. And now you can get both your labels as well as the series assigned to them. And you can see all of that information. Maybe I'll just break this up so you can see this a little bit better. There you are. So what it's going to do is it's going to list the labels and then it's going to list the series assigned to it. You're also going to be able to iterate through rows. So I'm going to say for index row in, again, df8, iterate rows is what you will use in this situation. And we can say print F, and we can say index, throw a new line inside of there, and then row, and run all those. And you can see how that information pours out there on your screen. And then finally, you're also going to be able to get a tuple that is going to contain your row data. So you can say for row in df8 and iterate tuples and print that row as well. And you can see how they come back in that situation. All right. So whole bunch of different ways we can iterate over series as well as data frames. And now I want to show you how to sort. This is going to be rather short. I'm going to get into sorting a little bit more here though later on. So let's use our data frame 8 here as an example. And let's go and print it out on the screen so that it stays there for us. All right, so good stuff. Okay, so what I want to do here is if we say df8 and sort index, well, if you call sort on index and the indexes are in order, it's just going to return you exactly the same results. However, if you don't want that, then you can actually get the reverse by putting ascending false, and you can see that it flips those indexes. And otherwise, so this is basically just uses it like this if your indexes aren't in order, and if you want to flip them, do it the other way. And if you want to sort by value for a specific column, how you can do that is say df8, and you're going to say sort in this situation and say values instead. And then just inside of there, say what specific column you want to sort for. So let's say I want to sort for D. I can do that. And now you can see they have been sorted. All right, so neat stuff. And that's the basics of sorting. And now what I want to do is get something more advanced. I want to talk about how to pass data to functions. Now in this situation, I'm going to import the system module. And I'm going to create some functions. And you're going to be able to pass data frames as well as series into functions. So what this guy's going to do is it's going to get profit totals. So I'll get profit total. And it's going to be passed a data frame. And I'm going to say profit series is going to be equal to data frame and profit. Now, this is information that I pulled from that CSV file that had my computer sales data inside of it. And then what I can do is say print F, and I can go total profit. It's just going to add up all the values inside of the column labeled as profit in my CSV file that I imported into a data frame. Like using all that stuff. And we'll just sum all of those values right like that. Okay, so there we are. So that's our function. And if we want to get it, we can just say get profit total and then pass inside of it CSDF. And you can see it added up all those profit totals and output everything on the screen. Now let's say that we'd like to receive a data frame that is going to split our contact information into two new columns, one labeled first name and the other labeled last name. So how do we do that? Well, I'm going to call this split name. It's going to receive a data frame. And inside of here, I'm going to put another function called get names. And it's going to have the full name that we get from the contact column inside of our CSV file. All right, so what I want to do here is I want to split first name and last name. If you don't understand what I'm saying, it's like contact is listed as Bob Smith. And what I want to do is split that into first name, Bob, and last name Smith, okay? Just so that you know what I'm talking about. And you can refer to the files at GitHub if you want to see this in more detail. So to do this, of course, I'm just going to go and get the full name and call split on it. So that's not that hard. And there we are. And now after I do that, what I want to do is create a series with first and last names in columns with those labels. So I'm going to say return PD dot series like this, and then I'm going to have F name and L name, which is where they'll be stored. And then after that, what I can do is say the index where I want this to go into our table is in the first name column and the last name column, new column. And that's how we're able to edit that information. So good stuff. Okay, so after we have that set up, I'm going to call names is equal to df and contact dot apply, dot apply. And apply is going to execute the function on all the names in our contact column. And the function I'm going to call is get names, and then df names dot columns is going to be equal to names. Whoops, I accidentally have to jump down here and jump right there. Okay, good stuff. And now I can return our data frame. Okay, so now that I have that all set, I can just call split name and pass in my computer sales data frame. And let's say I just want to get the first 5. And I had a little error. I named fill name. This should be full name. And there you can see that I ran that. And now that we have Paul Thomas, which was under contact, now split into first name Paul, last name Thomas. Okay, so pretty useful stuff. Now what I want to do is I want to assign people to different age groups based off of whatever their age is. So I'm going to say define create age groups, and this is going to be passed a data frame. As you can tell, we're starting to get into more complicated things. And I'm going to create some bins where this is going to be stored. So what we're going to do is we're going to break people into ages between 0 and 30, 30 and 50, and then sys and max size. So everybody's going to be divided into one of these groups, and they're like intervals. Okay, so 0 to 30, 30 to 50, 50 to the max size. And one thing to remember is that you must always have one more bin than you have labels. And these are going to be our group labels, and they are going to be less than 30. So this is what's going to show up in our table, less than 30. And then it's also going to be 30 to 50. And then we are also going to have greater than 50. So there's our labels we'll be using. And then what I'm going to do is I'm going to say age group is going to be equal to, I'm going to call PD cut, and cut is going to put values into certain groups based on intervals. So I'm going to say PD cut and our data frame, and we're specifically looking at the age, and bins is going to be equal to the bins that we have assigned already, and labels is going to be equal to the labels that we have assigned. Then I have to create a new column and return the new data frame information. So I'm going to say data frame, and I'm going to have a new column, and the name of that column is going to be age group, and then pass in our new age group that we have just worked out here, and then return our data frame. All right, so we did a whole bunch of complicated things in 5 lines of code. Pretty neat. So now what we can do is we can say create age groups and pass in our new computer sales data and run it. And you can see now that based off of whatever the person's age was, we assigned them to different age groups. So we're doing some really awesome finagling of data here, all using custom functions, which is excruciatingly powerful. Just going to do one more thing here. You're also going to be able to use a pipe to pass a data frame to multiple different functions. So we could say CSDF and pipe, and I can call split name and then pipe. So basically here where I was calling this and then I was calling this, I can do all this by calling pipe. So it's going to call split name with this computer sales data frame, and then it's going to call the next one, create age groups, doing exactly the same thing. So pipe again and create age groups like this, and we can call head on this if we'd like, and you can see that it does the same thing. All right, so ridiculously awesome things and ways to do really awesome things with functions. And now I want to talk about how we can align, reindex, and rename labels. Okay, so I went and created a series here, and you can see I created 5 values and 5 indexes here. All right, so let's say I'd like to get a slice of this. So series 6, and I want to start from the beginning to the 4th, and then I want to do another slice after that. And again, it's going to be series 6, and I want to start from the first item through the last item. All right, and I can print these out just so that you can see them here on the screen all of the time as we do all the things that we do. So there's that, and there's that. Okay, so what I can do is I can align both series by the union of their indices. So I can say SL and 1 and call align and SL2, and you can see there first there's a series, and you can see also that the indexes are different. However, I was able to align those together, so we have all of that information all put out there. We're also going to be able to align by calling series. So again, we're going to have align in this situation, but what we want to do is we want to join to the left. And whenever we do that, you can see exactly how they are going to align with each other as well. And you're just going to play with these until you find what works out for you the best. You also can be using your past series indices instead, just by changing this to right. And you can see how that changed. And you're also going to be able to get where the indices intersect by using join and inner, like that. So it's only going to show the results where they both have the same indices. All right. So it's just under the situation of what type of data you're working with, which is going to work best for you. You're also, I went and created two more data frames, DF6 and DF7. You're also, we can run those to see what you get here as a result. That's DF6 anyway. Okay, so we're also going to be able to come in here and we're going to be able to align our data frames, of course. So we can say DF6 and dot align with DF7. And you can see again, NaN values wherever they don't match up. And you're going to be able to use both left and right and inner depending upon how you want this information to line up and come out and work for you. Now, Reindex is going to allow you to align data by the index. So let's say we have series 6.reindex like this, and we have C and B, and then we have A. Run it, and you can see it's going to put everything in order based off of how you defined you want the indexes in order. And you're going to, of course, be able to do the same thing with your data frames. So let's change this to DF6, reindex, and instead, however, we have to do, let's go B and A, and you can see that works. And also, drop is going to be very similar to reindex, except it's going to receive labels that you do not want to include. So you could say DF6 and drop, and what you don't want to receive, which is A, and we're going to say axis equal to 0, boonk, and you can see A is not there any longer. And we're also going to be able to do the same thing with columns. Remember, anytime you see axis 0, you're dealing with rows. Anytime you see axis 1, you're dealing with columns. So in this situation, I'm going to change this to D and change this to axis 1 and run it, and you can see D disappeared as well. And another thing that is extremely useful is sometimes you would like to rename labels. So what we're going to do is we're going to come in here to DF6 and call rename, and then what you do is you have your columns that you already have assigned. So if you have a C and you want to rename it to something like men, you do that, and you just line up the old column names with your new column names. And I need another one here, and I will just have it be pets, and like that. And you can see now we were able to change those as well. Okay, so cool, interesting stuff. And up next, I'm going to show you something really cool, which is multi-index. Now, multi-level indexing is going to allow you to store data on multiple different dimensions. So let's say we have days, and I'm going to mark this as day 1. What we're going to be doing here is tracking calorie intake of different people in a study. So there's going to be day 1, and there's going to be multiple day 1 meals because you eat 3 times a day, or at least most people do. And then we're going to have day 2, and this will represent day 2 meals as well. All right, so there you go. You have your days. Then you're going to have your meals. And like I said, you're going to have 3 meals a day. So that's what that represents. And then this represents the next 3 meals. And now what we're going to be able to do is define our hierarchy index. And what we're going to do here is we're going to go list and zip. And what zip's going to do is it's going to pair our days to our meals array. So we'll go zip and days and meals. And then we're going to create a list of those paired tuples. And this is going to be really neat whenever you see this. Actually, why don't I just show you? So index like this, if you just want to see exactly what that looks like. So it's a bunch of tuples in a list. Okay. All right. So after we have that done, what we want to do is convert our list of tuples into each row and column. So hierarchical index is going to be equal to PD and multi-index from, and we're using tuples to define this, hierarchical index, and this is going to be really neat whenever it's all done. Okay, now what I want to do is I want to generate a random array. This is going to be the data that we're going to put inside of this multi-indexed data structure. So array 5. And what I want to do is I want to say random, rand, int. And let's say the person is going to eat between 500 and 700 calories per meal. And then, so that's going to be the random data. And this is going to be a 6x2 matrix. Then I'm going to create a data frame, which is going to be PD and data frame, and pass in array 5, and then pass in our hierarchical index. And then we're also going to have this be divided up into males and females, like that. And after I do all of that cool stuff, I can say D, F, and 9, boom. And you can see that how it's structured everything. So day 1, meal 2, meal 3. And how many calories were consumed by males and females, and so forth and so on. So you can see that you're able to structure data in really complicated ways. And we're going to talk about pivot tables here and other ways of working with data here as we continue. And let's do some more stuff. Like, let's say that we would like to go and find out what was going on here on day 1. We can do so. So day 1, boink. And it just gives us our information on our day 1 data. So a ridiculously great way to structure data. Let's say that you'd like to grab the first row as a series. We could do that. So location and 1. And you can say we grab just those 2 pieces of data. Let's say that we'd like to grab the calories eaten by the female on day 2 for the second meal. Yes, we can do that. So let's say that we want day 2 and we want our second meal. That's that. And we specifically only want what the female ate. And she ate 601 calories, and you can see 601 calories is right there. We can also go in and assign names to our day as well as our meals column. So you can see that day, it doesn't have anything, and meals doesn't have anything. Well, we can go in there and we can change that. So we can say df and 9 and index dot names is equal to and day and meal, like that. And then we can go df and 9. And you can see now day and meal are showing up down there. And what else do we want to do? Another thing we could do is we can get a cross section. So we could say df and 9, and that's cross section, what that stands for day 2. And this is going to give me the day 2 data frame. And that's exactly what it gave me. And you can see that it matches up there with our data. We could come in and let's say we wanted to get the calories for the first meal for both days. We could say df and 9 and cross section 1 and level is equal to meal, boink. And there we can get that for both of those days. And let's create another multi-index out of a data frame using something called a pivot table. This is something that's kind of specific to people that work with Microsoft Excel, which I'm not going to get into a Microsoft Excel tutorial here. But basically, okay, so we have all our data structured. We have it structured in almost exactly the same way. We just have everything in one big giant dictionary. All right, so that's all we got. So once we have that all set up, what we can do, let's say we have df14 is equal to PD and DataFrame and dictionary 6. Okay, so we have our new DataFrame. We're going to be able to say df14 dot pivot table, and you can define your values are going to be equal to D. So our values are coming from here, and our index is going to be equal to A and B, and then our columns are going to be equal to C. So there's your columns right there. And run it, and you can see that it put all of that information together, except where there's no overlapping data. We have sort of issues there. But anyway, that is just a rundown of multi-index and all of the different things you can do with it. I'm sure I'm going to probably touch on it a little bit later in the tutorial as well. But now what I'm going to do is talk about how you can handle and solve issues that come about whenever you have missing data. Okay, so I went and created a dictionary and a data frame, and if we run it, you're going to see what it looks like. Okay, so there's missing data in here, though. There's numerous ways we can work with that. One thing we might decide to do is drop missing data from our data frame. So we can say df10 and just drop NA like that. And you can see it is all gone. If there is NAs anywhere in any of these rows, that is just dropped and we're not going to use it. Another alternative, let's say we would drop all columns with any missing data. We could also say axis, and there's that. And you can see that we only end up with one column remaining. Another thing that we can do is drop a row unless it has at least 2 non-nan values. And how you do that is with threshold. And so thresh, and we said that we want at least 2 pieces of data. Whoops, it's thresh like that. And you can see anywhere we have 2 pieces of data, it's going to display that information for us. You're also going to be able to come in and fill in any of those pieces of nan values with fill NA. And you can put a value inside of there. Like let's say anywhere there's a nan you want to have 0 instead, you can do that. Another thing you can do, which is a little bit more interesting, is let's say that you'd like to fill a column with the mean of the column anytime there is missing data. Well, we can just say df and 10 and A in this situation and go and get the mean for that. And you can see it throws that in there. Sometimes that's good, sometimes it isn't. Another thing we can do is we can fill with whatever the previous value was. So let's get rid of this. And that is method. And it's called forward fill. And you can see anytime that we have a piece of data in there and a nan value shows up, we just fill it in. So you can see here was a 4, there's a 4, and there is a 4. And here you can also see 2 goes in there for that. And you can also do backfill, which is going to sometimes work and sometimes not. In situations which you don't have anything following, you're still going to have your nan values. All right, so a whole bunch of different ways to handle missing data. And now what I'd like to do is show you a whole bunch of interesting ways we can work with data. Okay, so here's some real world examples of how we can work with data. I'm going to go and get my computer sales data, and I'm going to work with it in multiple different ways. One thing that I want to do here is it's probably going to be helpful for me to see all of my column names. So I'm going to go and call columns on this. And now I just have my column names, and they'll stay on the screen and I'll be able to work with my data. One thing I'd like to do is I'd like to come in here and get my computer sales profit mean. So I can just go like this and mean, and I got my mean profit for each product that I sold. All right, so you might think, well, that's not all that wonderful. Well, let's say that I'd like to get the product with the highest profit. How would I do that? Well, I'm going to be working with multiple pieces of data. So anytime I do that, I'm going to have my data frame. And then inside of brackets, if I want to work with multiple different things, so I want to work with my product ID, and I'm just getting that from right here, see, product ID. Okay, so I want to get information from product ID, and I also want to get information from in regards to profit, and I want to say that I want to get the max, and access is going to be 0. And let's say that I want to get my first 5 most profitable product IDs. Okay, and that's what I was able to get. I was able to get 230. Well, I didn't need head here in this situation. I got the same exact thing. So what we got here is product ID Q5, whatever that is, gave me a profit of $230. All right, so that's my most profitable product. Let's say that I'd like to find out the number of people who made purchases from West Virginia. Okay, again, we're going to stack our data frames in this situation. And what I'm specifically looking for is state in this situation. So I'm going to say state, and I'm looking specifically for a state that is equal to WV. And then I only want data from state. So I'm going to put state there. And then I'm going to say count like this. And I've had total of 4 sales from West Virginia. Okay, so let's get more information. Let's say I'd like to find the number of purchases in 2019. Well, I'm going to use length this time to get this information. So again, CSDF and CSDF. And I'm specifically working with a year. So I'm going to go year. And I'm going to say that I'm specifically equal to, or interested in the year 2019. And then I'm going to call index on that. And I can see that I made a total number of sales of 14 products in 2019. All right, let's get even more complicated. Let's say I wanted to get the number of sales for each product type. So I'm going to say CSDF. And I'm interested in product type this time. So product and type. Oh, that's product ID, ID. And I call value counts. All these things I have already covered in this tutorial. And you can see the different products and the number of times I sold each of those products. Now let's say I'd like to get a list of customers that bought a specific product. I can say CSDF. And inside of parentheses, I can say CSDF and lead. Actually, I'm not going to do parentheses for this. CSDF. Get that out of there and get that out of there. And product ID. And the specific product I'm looking for is MO1-F0024. And I'm interested in the contact's name. Boink. And you can see there's all the people that purchased that specific product. Now let's go do something a little bit more complicated. Let's say we would like to find out how many made a website purchase for a profit over $200. So again, I'm just stacking these data frames. So I'm going to go like this, and then I'm going to do parentheses, CSDF, and I'm looking for lead. And that's where I have where the person purchased the product, whether it's from a flyer or from a website or whatever. So I'm specifically looking for a purchase made on the website. And then I want to also find CSDF and profit, which is going to be, let's make it be greater than $150 instead, just so we get more. And then I'm specifically looking for the lead, which is going to be the website. And then I want a count. Boink. And 2 people made a purchase of over $150 on the website. So that's not very good. And this is obviously sample data. And then for the final example, let's do something really crazy. Let's say I'd like to find out how many products profit amounts end with 89 cents. Okay. So how would I do that? Let's split this off. So I'm going to say CSDF.profit like that. And then I'm going to say apply. And I'm going to use a lambda here, which is going to be cents. So I'm going to pull the cents from the end of the profit amount. So I'm going to convert this into a string, and then I'm going to split it at the decimal point, and then I'm going to get the end of it, and like it splits the dollars from the cents, and I'm going to say that I'm looking specifically for 89 cents. And then I say value counts like this and like this, and there are 4 products that's profit amount ends in 89 cents. Okay, so there's a bazillion different ways of going and digging through data. And to end this whole entire tutorial, I'm going to show you different visualization options inside of Pandas. Okay, so the very first thing I'm going to show you a little bit of matplotlib capabilities, and I'm going to show you just basic Pandas stuff. I'm going to make a separate tutorial just for matplotlib so that you will completely understand it as well. All right, so if I want my plots to be displayed inside the notebook, I have to also go % and matplotlib and inline like this, and then they will show up directly inside of our notebook and look wonderful. Okay, so let's say I would like to create a histogram, and if you don't know what a histogram is, it provides an approximation of the distribution of results. And what we're going to be doing here is we're going to be working with dice that we're going to roll 5,000 times. And what I want to do is I want to chart both the frequency or the probability, if you roll 2 dice, what your results are going to be, and also a histogram, which is going to be the total number of times each of those scores came up after 5,000 rolls. Again, if you don't know what a histogram is, check out my statistics tutorial. So I'm going to create a data frame that's going to reference all this dice stuff. So I'm going to say data frame, and let's go and create all this stuff. So I'm going to say that I want to go and create random int, and the values are going to be 1 to 7, and I want 5,000 dice rolls. So that's going to simulate rolling a 6-sided die. And I'm going to define my column to be equal to histogram, like this. And then what I'm going to do is say df and dice, and I'm going to show you the odds of rolling all those different dice on the same visualization. So I'm going to say df and dice, histogram, and then we're going to also go random dot randint, and again 1, 7, and 5,000 rolls. So we're actually going to show 2 things on one chart. And then I say ax is equal to df and dice and plot, and I want a histogram, and then you're going to define your bins, and it will be 12, and alpha is going to basically be like opacity for the chart. I want everything to show up half opacity so that you'll be able to see both at the same time. And whenever you're working with histograms, this is where bins comes in. Basically, you create the histogram by dividing the range of values into bins or buckets, and then you're going to count how many times the results fall into each of the bins. And there's going to be 12 different bins because there's 12 different ways of rolling the dice and different results. And if I roll it, or if I run it, you can see in blue the histogram results, which actually ended up getting the numbers after 5,000 rolls almost the same. And you can also see the odds of rolling those dice as well. All right, so that is how we can calculate using histograms, or display data showing histograms anyway. Now I'm going to show you how to do line plots in a couple different ways. So let's say I'd like to make, I'm going to create a series here, and series. And what I want to do here is generate random values again. And you don't have to, obviously you don't use random values all the time. You can use any values that you want. I'm just doing this for simulation purposes. Okay, so I want 1,000 values here. And I'm going to set my index to be equal to, and I'm going to chart this over a date range. So I'm going to say index is equal to PD date range. And I'm going to start the date to be 11, 15, and 2017. And how long I want this to continue is 1,000 days. 1,000 days. And then what I'm going to do is my series is going to have cumulative results. So as each value comes out, it's either going to increase or decrease the line plot. So cumulative sum. And then I just call series 5 and plot like that. And boom. And it went and created simulated results of a plot. Now we'd actually be able to do this with multiple different plots. So let's change this to 3 different results. You can use pull data from 3 different areas as well. The only difference is you're going to have to come in here and you're going to have to define different columns. So if you're given 3 different types of results, well, you're going to have to provide A, B, C for those different types of results. Cumulative sum, exactly the same, except I'm going to do this with a data frame, obviously, not a series. So I'm going to call this data frame 15 and change this into a data frame as well. Everything else here is going to be the same, except this is data frame 15, and so is this. And then data frame 15, data frame and 15, and run it. And you can see that you can go and chart multiple different values or strings of values. So pretty neat. And whenever we get into matplotlib, like I'm using currently, I am using the plots for pandas, and we'll be able to do really cool things. There's so many different ways to chart data you'll see in upcoming videos. Let's say I'd like to make a bar chart as well. Let's get rid of all this. And I'm going to say pd dot data frame and mp dot random number, and let's say I want 5 of them, and I want to plot those values as a bar chart. Just say plot and bar, and whoops, what did I do wrong? I put a comma inside of there instead of a period, and you can see it took those 5 random values and then just went and created a random bar chart. All right, so neat stuff. Going to be able to make multiple different bar charts as well. So let's come in here and let's say we have values is equal to A, B, C, D, okay? And then I'm going to create a data frame here. Data frame, let's just make it 15, is equal to, and then I'm going to call random again, and I'm going to say 10 to 4. Columns are going to, let's get rid of this, plot that one out of there, and I'm going to say that I want my columns to be equal to the vowels list. Then go df15 dot plot dot bar, and you can see that it was able to chart all of those different types of random values, multiple different bar charts, all in different segments. So really cool stuff. They're also going to be able to do area plots. Why don't I show you matplotlib as an example of just some stuff you can do. Let's say I want to define an X range and value. So this is going to be on the XY axis. So I'm going to say my X range is going to be a range of values from 1 to 15. And I'm going to say Y values are going to be equal to, and let's just go and create a list. So there we are. Just make sure you have the same number of X's and Y's. Now I'm going to be able to do a lot of things here. So I'm using matplotlib now. Okay, so let's say I want to have my fill and change my fill color. So I'm going to say fill between and X and range and Y and vowels. And I want the color on this. I can have it be any of the colors that are defined. Let's make it sky blue. And let's make the alpha, which is opacity, be half of what it normally is. I can do plot and show, and you can see it plotted out all that information, which looks really cool. And you'll also be able to do multiple different areas all at the same time. So let's come down here. Let's say pd dot data frame and np random and rands, and let's 10 to 3. And columns equal to, and I'm going to just go A, B and C for the different areas. And then I want to plot using an area, and there's that. And whoops, what did I do wrong? Name seems not defined. Oh, I forgot to put this in quotes. There you are. Run it. And there you can see multiple different area charts. So really neat things. The color's a little whacked out. I definitely change those colors. But there you can see that. And why don't I show you a scatter plot, because you're going to use those a lot. So PD, and again, DataFrame, and NP dot random. I use all other software to do plots, and that's the reason why I'm covering a lot in regards to visualization with pandas, but I'm not going to cover every single thing ever, because I use other things, which I will cover in future tutorials. Hit the notification bell if you want to know. And actually, by the way, if you're actually still watching this video, please take the time to tell me, so that I know people actually watch these videos till the end. Makes me feel good. All right, so scatter and A and Y equals to B. And this is just going to create a scatter plot with 100 random values. And there you can see 100 random values just scattered all over the place. And let's say that you'd like to do one. Let's do something else here. Let's just get rid of all that. Actually, let's keep it. And let's change this to DF15 again. And a data frame again. Random, I'm going to change this to 54. And we'll have our columns be A, B. And I'm going to use multiple different scatter plots from multiple different pieces of data. Go down to the next line, and I'm going to say AX is equal to DF15 dot plot dot scatter. And what is X going to be? I'm going to use A. And what's Y going to be? I'll use B. I'm going to set my color for the first scatter plot to be dark blue. And I'm going to give it a label, which is going to be equal to group 1. And then I'm going to go df15 dot plot dot scatter, and X is going to be equal to, and you can see how these different pieces of random data are tied into the columns A, B, C, and D, which there's 50 of them, and then we wanted 4. This is going to be Y is equal to D. Change the color so that we can see it. Let's just make it orange. And we'll say that the label is going to be equal to group 2. And then AX is equal to AX. And you can see now we have the dark blue dots as well as the orange dots. And to finish off the whole entire tutorial, who doesn't like pie? So I am going to go and show you how to make pie chart. NP dot random rand for index on 4 slices, and the indexes are going to be A, B, C, D, and then I'm just going to name this pie, and then to plot it, the pie chart dot pie, and figure size is going to be equal to 6 by 6. That looks good. Run it, and there we created pie chart. All right. So pretty cool, awesome stuff. All right, and finally, this is how you set up a virtual environment in Anaconda and install all the libraries you need. So you have Anaconda open. If you don't know how to install Anaconda, I have a link in the description. So you go to Create, click on Create, and then you go and you give your virtual environment a name. I called this Pandas tutorial. I'm using Python 3.7. You can use 3.8. It doesn't matter. Click Create. Then what you're going to do is you're going to click on environments over here on the left side and make sure you have your new virtual environment selected. And then over here, you're going to see everything that is already installed. You're going to install some new libraries though. So you're going to switch this guy to not installed. And then you're going to type in Jupyter. We're going to use Jupyter Notebook, and then you put ticks in all of these different lines here, or these boxes here. And then you come down to the bottom of the screen and click on Apply. And whenever you do, it's going to show you all the different things that need to be installed. You're going to click on Apply. And then you're going to do the same thing for NumPy. So just type in NumPy, select NumPy here, and then down at the bottom, click on Apply. And then you're just going to apply, and it's going to install everything. And then what you're going to do is to proceed to type in Pandas LXML, HTML5, lib, beautiful soup. We're not going to use every single one of these, but these are going to be some very common things you're going to need to use pandas and NumPy and matplotlib and all the other things we're going to cover in this video. So just go and put all of those in. And then after you have installed every single one of them, go back to Anaconda Navigator, Home, and click on Jupyter Notebook, and you're ready to proceed with everything covered in this tutorial. So hopefully you guys enjoyed this. This took me forever to make. And like always, please leave your questions and comments down below. Otherwise, till next time.